Hello, good afternoon everyone. Today I am going to discuss regarding how the muscle tone is maintained. We are going to see this particular topic as it is very much important topic, part and parcel of the CNS, which is to maintain the muscle tone and how it is maintained. Some of us, like some Bollywood heroes and some workers who are working very hard for their daily wages in the farms, they have developed this particular body tone. This is a state of contraction of the muscle. At rest also, they are showing this particular shape, which is not possible, of course, for everyone. But for day-to-day activities also, you will require some amount of muscle tone. Then only it is possible to do some daily activities. So let us discuss this particular topic under these headings. First, we are going to see the definition of muscle tone. What are the mechanisms for maintenance of this muscle tone? There is a role of reflexes in maintaining the muscle tone and the applied aspect of this muscle tone. As if we are discussing this particular topic in all these headings, it will be very much lengthy topic. So what I have decided is that I am going to divide this particular topic into two sessions. In this particular session, I am going to discuss the definition, the mechanisms and the role of reflexes. And in the next session, I will be discussing the applied part of the muscle tone. So let us see how the muscle tone is defined. Muller was the first scientist who defined the muscle tone. He defined tone as a partial state of muscle contraction at rest. So whenever your body is at rest, it shows some state of contraction, which is not a complete contraction, it's a partial state of contraction. And this is termed as muscle tone according to Muller. Then came the definition which was given by the scientist Postur. He defined the tone as resistance which is felt to the passive movement. So suppose you are doing any passive movement on any person, there will be a resistance which is felt, and this resistance is termed as tone according to Postur. So if a person is in a normal relaxed position, the resistance will be felt whenever you are moving the limb at a joint. And this resistance is due to the mechanical properties of the limb itself. The joints which are involved at the particular moment and the ligaments and the muscles which are involved in the particular movement. Now this muscle tone can be of two types. If its first is phasic tone, so whenever you are changing the posture, there is a rapid stretch on the muscle and which is detected by the muscle spindle, which is a receptor which detects the change in the length of muscle. We have discussed already this particular topic at the time of the receptor itself. Or there was a repetition in the spinal cord stretch reflexes itself. But to revise again, muscle spindle is a receptor which detects the change in the length of muscle fiber. So whenever there is a rapid stretch, it will change the muscle length and then accordingly the contraction will be seen. And this particular tone is known as phasic tone, and the response which is seen is very rapid and short. Then comes the postural tone, which is also termed as static tone, and this is due to steady strained stretch. So if you are standing in a standstill position, a particular posture is given to the body, mainly due to the anti-gravity muscles of lower limbs. There will be tendons and attached muscles will be showing the contraction of these muscles, and this is a steady, sustained stretch. This is termed as postural tone or static tone. Now the control of the muscle tone may be the phasic or maybe the static, but it is done at the level of the spinal cord, spinal control, and above the spinal cord, the supraspinal control. So it is having dual control, the spinal control as well as supraspinal control. Now we will discuss the spinal control, how the spinal cord is covering this control. It is mainly through the stretch reflex. This is the basic mechanism for the tone to be activated. The partial state of contraction, how it is possible. And for stretch reflex to occur, the muscle spindle along with the alpha and gamma motor neurons are mainly implicated. So So these are the part and parcels of the stretch reflex. So as we are going to see this particular muscle fiber, see, this is muscle spindle. So what it is, it's a fusiform structure and it is situated in the muscle fiber, and the tendinous part, it is of the muscle itself, it is showing the tendinous part. So it is sharing the tendon and it's a fusiform structure. It is having two parts, extrafusal fibers and small intrafusal fibers along with the sensory and motor nerve fibers. So this is the structure, and in that structure you can see in this particular figure also there are large extrafusal fibers and small intrafusal fibers. These intrafusal fibers may be 4 to 12 are present in there, and they are smaller in diameter, and they are of two types. One is nuclear pad fiber. This one is nuclear pad fiber, which is bulged inside in the center, and these are the nuclear chain fibers, which are chain-like structures. So you'll be having two types of fibers, nuclear pad fibers and nuclear chain fibers. And both of these types of fibers are involved in monitoring the length of the muscle fiber and the velocity of contraction. Now it is supplied, this is having a sensory supply via two fibers. One is the primary nerve endings, which are also termed as type 1A fiber, and they are going at the center of the intrafusal fibers. And type 2 fibers, they are also going to the center of these intrafusal fibers. So this is what is sensory supply of the muscle spindle. And whereas the motor is via the alpha motor neuron and gamma motor neuron. The gamma motor neurons are for the intrafusal fibers, whereas the alpha motor neuron fibers are for the extrafusal fibers. So if you again concentrate on this figure, this is how it is supplied. This is a particular enlarged figure of the intrafusal fibers. You have the nuclear band fiber, nuclear chain fiber. Nuclear band fiber is bunched in the center, and it will be having the sensory supply, which is spiral nerve supply, and this is via the type 1A fiber, which is also termed as primary ending. And then it is also having the secondary endings, that is type 2 fibers, which will be at the periphery, and alpha and gamma fibers as the motor fibers. So, in short, what we have is group 1A fibers are responsible for dynamic response also and static response also. So, both of these are involved via the group 1A fibers, as group 1A fiber is supplying the nuclear band fiber. So, whenever there is a change in the length of the muscle, these fibers will be activated and the muscle will be stretched. Whereas if we are standing still due to the static response throughout the sustained stage, the group 1A fibers and nuclear chain fibers will be activated. Whereas group A2 fibers, they are responsible only for the static response as they are supplying the nuclear chain fibers. As many of the books are mentioning the primary and secondary endings, you can remember like this also. Primary and secondary endings are responsible for static response to maintain the flow, and the only primary endings are responsible for dynamic response. So that is how it is maintained. Then it also has another receptor, which is known as Golgi tendon organ. This is present at the tendinous part of the muscle, and that detects the tension on the muscle. The force of the muscle contraction will be judged by this particular Golgi tendon organ. Now, how this tone is passed on via these muscle spindle to the spinal cord. So you have these afferent pathway, one A fiber, two fiber, and one B fiber. Now, one A fiber, as we have just seen, it is from the center of the intrafusal fiber, going entering the dorsal horn and going towards the alpha motor neuron. So it is completely here. From this central part, it enters the dorsal horn and directly goes towards the alpha motor neuron, whereas type 2 fibers are from the periphery of the intrafusal fiber. They will also enter the dorsal horn, but instead of direct insertion on the alpha motor neuron, they will enter through the interneurons. Then there are some fibers which are type 1B fibers. They are coming from the Golgi tendon organs, and they will be again entering via the interneurons to the alpha motor neurons. So this will be the afferent pathway, which is the information coming from the muscle spindle. So from the receptor, this particular information will be going towards the spinal level. Now, how the spinal cord is going to control this? With this, motor fibers are of two types, alpha motor neuron and gamma motor neuron. Alpha motor neuron will be having all the inputs, and this input is going to give the information to the extrafusal fibers. So they are responsible for the stretch reflex, because this is how the change in the length which is given by this afferent pathway will be given to the extrafusal fiber. Now, there is another neuron which is gamma motor neuron. This gamma motor neuron will give the information to the intrafusal fibers, and these are the intrafusal muscle fibers. They are responsible for the dynamic response. So, whenever there is a change in the length, these will be activated, and whenever there is a static posture, static tone, these will be activated. But both of these, as they are interlinked, both of them are responsible to develop the stretch reflex, and then there will be a reflex contraction. How the alpha motor gamma motor neurons activity causes the intrafusal fibers to contract. This stretches the primary sensor linkings, and along with this, there will be discharge of alpha motor neurons causing the depolarization. This also causes the extrafusal fibers to contract, and thus the stretch reflex will be activated, and there will be development of partial state of contraction. This is how muscle tone is maintained. Now, according to the activity, whenever you require more amount of reflex, more amount of tone, this discharge will be accordingly adjusted. Now, you have the reciprocal inhibition inside our body. So, whenever there is a contraction of one group of muscle, the antagonistic muscle will be inhibited. And due to this, the change in the position is possible and the movement is possible. So this is how the spinal cord is basically going to control the muscle tone via the stretch reflex. So it is going to alter the discharge of these motor neurons, and they are going to change the stretch reflex, and this is how it is happening. But this muscle spindle and gamma motor neurons, they also receive input from the higher centers, and this input may be facilitatory, may be inhibitory, and according to the facilitation or inhibition, the muscle spindle activity will be changed, and then the tone is adjusted. Now, what are the influences coming from the higher centers? So there are some medial pathways like reticulospinal, vestibulospinal, tectospinal. These are the tracts which terminate on the ventromedial area of the spinal cord. So these are the higher control over these spinal cord, and these spinal cord then will control the activity of axial and the proximal muscles. So these axial and the proximal muscles, they are responsible for the stature or static posture of our body as we are in axis. So whenever you want to maintain the static tone, this is the higher control over the spinal cord, and then which is coming to the stretch reflex and controlling the activity of axial and proximal muscles. It also has one control, especially from the red nucleus, and that tract is supraspinal, and that is the lateral pathway. So it is terminating on the dorsolateral area of the spinal matter, and this is specifically for the control of distal muscle activity. So you have a higher control of the distal muscle activity from the supraspinal tract. So whenever you want to change the distal muscle activity, it will be changed via the spinal cord itself or the supraspinal pathway. And accordingly, whatever the need of the body, whatever the requirement, whatever the plan of your movement, these activities will be there. So you have one facilitatory area in the pons which receives information from the ascending tract. So sensory information is gathered, and it also receives information from the cerebral cortex, the basal ganglia, the cerebellum, that gives the spontaneous discharge, and there is a continuous activation of gamma motor neurons. And if these motor neurons are activated, the stretch reflex is activated and muscle tone is maintained. Along with that, you also have the inhibitory area. Actually, it is present in the lower part of the medulla. It is not having any intrinsic activity, but it has some suppressor areas with caudate nucleus and cerebellum. They give the inhibitory impulses to the gamma motor neurons, and due to the inhibition, the muscle spindle discharge will be less and the stretch reflex activity less. So in this particular figure, it can be revised again. So for maintaining either the movement or the posture, you require the stretch reflex. And for stretch reflex, you have two controls. One is at the level of the spinal cord and one is supraspinal, so above the spinal cord. The spinal cord will be working through the muscle spindle, that is via the alpha motor neuron fibers and gamma motor neuron fibers. So it will adjust the discharge of these two neurons, and then it will cause the activity to be maintained of stretch reflex, and it will automatically maintain the tone of muscle. It is controlled supraspinally by these other parts of the CNS. So it will be having facilitatory part also, and it will be having inhibitory part also. Say for example, this inhibition, the cortical suppressor area, the basal ganglia, the cerebellum, they are going to inhibit the discharge of this. And due to the inhibition, the stretch reflex is inhibited, and the tone will be actually determined that particular point, whatever is required. And if there is no inhibition, then there is a partial facilitation, which is through the gamma motor neuron, and then the stretch reflex is activated and maintaining the normal muscle tone, that is a partial state of contraction. So at rest, there will be a somewhat stimulatory discharge from the gamma motor neurons, which is causing with the alpha gamma linkage the stretch reflex. Now, apart from the spinal and the supraspinal, the other factors are there which influences the discharge from these gamma fibers. Say, for example, if you are anxious, that increases the discharge, then you get hyperactive tendon reflexes. You can yourself experience this. And say, for example, unexpected movements are there. There is a protective mechanism you must have seen. Say, for example, someone is coming from the back and suddenly it taps on your head or back. It's an unexpected movement. It will also increase the gamma equivalent discharge, and there is increase in the contraction which is seen. Take for example, stimulation of the skin, especially by the noxious agent. So whenever you are pinching, pricking at that particular point, the gamma equivalent discharge will be more, and the contraction, which is the basic muscle tone, will be increased due to increase in the gamma equivalent discharge. The physiological significance is that it can increase the discharge to the gymnastics maneuver, which is reinforcement maneuver, which very well can be revised in your practical classes of CNS. So that is all regarding the discussion of the normal maintenance of the tone. And this is a figure which shows the tasks which are involved in the activity of maintaining the tones. So these particular figure, this part is sensing part. and this is your motor part, and in that motor part you have the disturbing movements, fine movements, and they are actually the inhibitory. And the tract involved are corticospinal, rubrospinal, and reticulospinal. So these are the tracts which are involved for distal limb movements. So fine movements will be controlled, and mainly they require the inhibition also, and that is why they are inhibitory tract. Whereas these axial and proximal limb movements, they are generally excitatory, and they are through the vestibulospinal, reticulospinal, and ectospinal tract. So you can remember this part of the figure, which is very commonly asked in the Viva. The questions are asked on this. So, to summarize, what we have seen is the definition that tone is a partial state of contraction. It is having dual control. One is via spinal cord and the other is above the spinal cord level, that is supraspinal. Spinal control is through the stretch reflex, and it is adjusting by changing the gamma motor neuron discharge. Whereas the supraspinal is having two parts, facilitatory control and inhibitory control, which is via the bulboreticular, facilitatory or inhibitory area. So thank you very much, and thanks for listening this particular topic. In the next session, I am going to discuss the applied aspect of